So today the topic which we are going to see is sulfur hexafluoride SF6 circuit breaker. So far we saw the different types of circuit breakers like IL circuit breakers. So now, what is the difference between these different types of circuit breaker is the medium which we are using for quenching the arc. That is the thing which what is the based on this only the different types of circuit breakers are classified. So now we are going to see the SF6 circuit breaker. So in this SF6 circuit breaker, we will be using SF6 gas as a medium between the contact for deionizing the particles which is present between the contacts. So first, before we are going into the operation and the working principle of the circuit breaker, SF6 circuit breaker, let me see what are the properties of this SF6 gases. So what are the properties of this SF6 gases is it is an electronegative gas and it has a tendency to absorb the free electrons, and if we are forcing this SF6 circuit breakers with the high pressure between the contacts, the arc will be easily absorbed by this SF6 circuit breaker. And why how it easily absorbs is this, since it absorbs the free electrons, it does not allow the further formation interruption of the current, and therefore it immobile negative ions will be easily absorbed. So therefore this SF6 circuit breaker has a high efficiency in absorbing the ionized particles. So next is, since with a very quick time it will be forming the dielectric medium between the arc. It means that it increases the arc resistance as very soon. So that is the advantage of this SF6 gases. So these type of SF6 circuit breakers are SF6 gas filled circuit breakers are used at the high voltage and the high power applications. So these are the properties and the advantages of the SF6 gas. Okay. So now next we are going to see about what is the how the construction of this SF6 circuit breaker here. So you can see the circuit schematic diagram of this SF6 circuit breaker. Here you can see the SF6 gases is entering into the chamber, and this chamber is called as the arc chamber. So we are forcing the SF6 circuit breaker into this gas into the arc chamber. So this is the fixed contact and this is the moving contact. Now the gases has an option to enter into the moving contact hole also. Okay. So now this is an fixed chamber, and this fixed chamber is having the arcing horn is present at the fixed chamber. No. So you know that circuit breakers at the normal operation of the condition, it will be not, it will be closed. When a fault occurs, the circuit breaker gets opened up. So when the circuit breaker gets opened, this SF6 gas starts entering into the arcing chamber. So you know what are the properties of this SF6 circuit breakers. So since it easily absorbs the free electrons, therefore dielectric strength is easily formed between the contacts. Okay. So at the same time, the SF6 gases which is entering into the chamber is also enters into the hole which is at the moving chamber also. Okay. So this is the construction. Now we can go for how the points regarding the construction of this SF6 circuit breaker. So it consists of the fixed moving chamber and so it consists of the fixed and moving contacts enclosed in a chamber. So the chamber is filled with the SF6 gas reservoir. So when the contacts are open, the gases will come from the SF6 reservoir will be entering into the arcing chamber, and it will interrupt the current between the chamber. So now the fixed contact is having the arcing horn, and the moving contact is filled, it has a rectangular hole where the SF6 gas will be entering into the hole once it comes from the SF6 reservoir. Now the tip of the contact, so both the tip of the moving contact as well as the opening contact, both the tips are coated with the copper tungsten arc resistance material. So this is the thing, both the closed and the open contacts, both the tips are filled with the copper tungsten arc resistance material. Since this SF6, what is the disadvantage of this SF6 is, it is the SF6 gas is costlier, so we cannot Once operation finished, we cannot remove this SF6 gas. So it has to be reconditioned, and again the SF6 gas has to be used for the operation working. So in the closed position of the breaker, the contacts remained filled with the arcing tank. So since the dielectric SF6 gas 2 to 3 times that of the air, dielectric strength than the air, 2 to 3 times than the air, so it can interrupt the current very easily, and it is a noiseless operation when it is and the whole arrangement is fixed inside the closing chamber. Therefore we cannot hear much noise outside, and no atmospheric conditions will affect this operation. No moisture will enter into the operation. So it is a very best operating circuit breaker when compared to that of the oil circuit breaker and blast circuit breaker. Here, there is no much problem with respect to the fire accident, because SF6 gas is inflammable and it easily absorbs the free electrons also, and there is no more carbon deposits present here. So if you are using oil or something else only, we'll be having much carbon deposits here. So here we will not be having any carbon deposits, and therefore nothing insulation will be formed between the contacts due to the duration of the oil or something like such problems will not be present in this SF6 circuit breaker. And this since it is present inside the closed chamber, we don't have much problem with respect to the atmosphere. So maintenance is also very easy, and we don't have any additional equipments like isolating switches, or like we don't have any additional devices with the SF6 circuit breaker, since the cost is also very less because of this. So these are the advantages of this SF6 circuit breaker. Let me see the disadvantages of this circuit breaker. So it is high cost. The gas is high cost. That is the main disadvantages of this circuit breaker. And so it is we can use this as SOC circuit breaker for 10 megawatts up to 20 megawatts, and interrupting time is less than 3 seconds. So it is developed for only the high power applications. So that is the advantage, and where we can use it for applications. So these are the things which is regarding the SF6 circuit breakers. So if you have any doubts, you can post it. Okay.